Hello, everybody. It's a new year, and I want to say a big happy new year to everybody. I wish you all the best of luck in this new year 2024. It's sure to be absolutely amazing. We're going to be having an amazing afternoon session where we're going to be talking about Azure and AWS Cloud, a pathway to DevOps and efficiency. So we're going to start the new year with a big bang, talking about DevOps and how we can integrate DevOps into our coding experiences. But I'm not going to talk too much about that because obviously we've got our presenters this afternoon that will be talking more and sharing more and giving you an entire workshop of how DevOps looks and feels like. So let me just first introduce myself. My name is Susan Falola, CEO and founder of Jubix Limited. I am the visionary, creator, kind of implementator around the GTLRA, as well as also obviously focusing on the trio of products that we have. I'm going to talk to you a bit more about the GTLRA. So the GTLRA, which is the Global Textbook Leadership Program, it leads with transparency, shared learning, and basically provide the world with a diversified recruitment agency. So let me just share my screen. Where's my screen now? Slideshow. Fantastic. So yeah, welcome to the future of work, innovation, and leadership. GTLRA leads with transparency and shared learning to provide the world with diversified recruitment agency that advocates inclusive change across all markets to share financial equity across platforms. So we really want to, provide like an ecosystem, a marketplace where we can actually share equity across platforms that are already existing. Our mission is to provide this service for internationally, both within and outside schools and universities to drive innovation, shared knowledge, and facilitate cross-border leadership, thus paving the way for a brighter, more interconnected future. And I'm sure from the workshops you've seen so far, as well as the one that you're going to see this afternoon, that you'll hear a lot more about that. So this is where I will, pass it over to my presentees for this afternoon. So we have Shruti and Shaibu. Hi, over to you guys to present this afternoon's workshop. And let me just share your screen, Shruti. Okay, over to you guys.
Okay, first of all, Happy New Year to everybody. I am Shruti and I am from India. I'm a recent electrical engineering graduate. And apart from electrical engineering, I have an interest in software and cloud and DevOps domain. Previously, I have worked with a company where I have worked with Azure infrastructure as a service models. And now, presently, in Jubix, I've been working for 5 months now. And I've been working here as a front-end developer and Jubix DevOps developer as well. So I would like to welcome you all on our workshop. And first off, we will start off with the cloud computing introduction. Later on, we will talk about some DevOps concepts and how we integrate cloud computing with DevOps. And later on, we will have a little demonstration on Azure platform as well. So welcome you all here. Introduction to cloud computing. What is cloud computing? Cloud computing is a technology that delivers computing services including storage, processing, and software over the internet, allowing users to access and use resources without the need for local infrastructure. By this definition, well, we can see that cloud computing is a technology that allows users to provision some resources, some storage and processing softwares, and this is a little edge over local infrastructure. Well, what is a local infrastructure? Local infrastructure is basically an on-premises data center or a cloud, a computing servers or devices, networking devices, CPUs, Wi-Fi routers, storage devices, and also data processing and interpreting devices as well. Well, for the need of cloud computing, we do not actually require local infrastructure while talking about cloud computing. Well, so this is because local infrastructure has lots of drawbacks in this era. Local infrastructure, first of all, has a lack of scalability. Uh, Scalability issue is Something, for example, you have some user demands, and as the number of user demands increases, uh, actual local infrastructure, you might not be able to scale them up or down as the number of demand increases. So you cannot be able to invest in computing devices, CPUs, and data storage devices in such short amount of time. You would need cloud computing for that. Another drawback is lack of global user interface or user bases. The people living across the countries, they might face network issues or latency issues while using your software or your services. Uh, Cloud computing also help us achieve improve that by creating data centers all across the world and creating replica sets or availability sets so that each user can have access to your efficient infrastructure and softwares. Another major drawback which local infrastructure lacks is lack of disaster solutions. So what might happen if you lose some of your important data, or what might happen if uh, your computing services or your CPU lost internet connection or lost some other key information or just malfunctions. So for that, cloud computing comes as handy as well. It would create, as I said, replica sets so as to ensure availability and reliability delivery of your services. Before coming to the features of cloud computing, let us first have a little facts and figures about it. Cloud computing is up to 40 times more cost effective for small and medium businesses compared to running an in-house IT systems. According to Microsoft, cloud computing is 93% energy efficient and has 98% lower carbon emission than on-site data centers. This is because the data centers created and provided by these cloud providers are based on energy sustainable models. For example, wind and solar power plants, so as to ensure they are eco-friendly and produce lower carbon emission. Talking about business, 81% of all businesses and organizations have reported having multi-cloud strategy in works, having generated over $623 billion revenue in 2023 globally. This is an impressive amount. Any internet domain or uh, any what technology domain has ever grasped in short amount of time. Okay, we can now move forward to all the features provided by the cloud. First up is the flexibility. As we have talked, as the number of user demands increases, cloud makes sure that you have enough resources available to provide best content delivery or best service delivery to your users. If these resources might scale up or might scale down as the user demands uh, keeps changing. Okay. Reliability, well, it's similar to flexibility, well, because cloud makes sure that your services have been delivered 99.99% of the time, and they have creating availability sets all across the data centers so as to ensure efficient model. Okay. Security, all your servers and data are being secured by the cloud by multi levels of authentication and authorization. Any person who even has smallest access to the cloud might not be able to configure or manage your servers or data. These are all contained in security and compliance model by these clouds. Cost effectiveness suggests that you only have to pay for the resources that you have provisioned or you have used. You Some of the cloud computing provider have per hour model to calculate these costs, but some of them have per minute models as well for more precise calculations. On demand service suggests that you can scale up hundreds or thousands of virtual machine at a time by single scripts, and you can also ask for thousands terabytes of data storage applications or services as well. Easy collaboration suggests that you can work on a same project by people of your own team from same company or from the people from another organization as well, which ensures you have best service delivery, and efficient models. Let's go and see some of the key characteristics provided by the cloud. First up is virtualization. You can create a virtual machine by say on US region, and you can access that machine just like you use your own personal computer or your personal laptop by sitting anywhere from the world. Resource provisioning means you can provision virtual networks, subnetworks, networking gateways, local machines, virtual machines, data storage and processing, which means you, for example, people or company have different kinds of data and they might to process this data in different kinds of storage services or processing services. Some of these data might require AI and ML. So for these concepts or these requirements, cloud also provisions data storage and processing services, different kinds of them, and APIs for them. Network infrastructure suggests that uh, people, sorry, cloud computing also ensures networking gateways, load balancers, inbound outbound traffic control, and etc., which might all include in network infrastructure of your application devices or infrastructure models. Security and compliance, which means, as we have talked earlier as well, that uh, everybody should have some role based access on these cloud platforms. People can have access to view the resources or configure the resources but not delete the resources. These are very granular type roles provided by almost all cloud providers so as to ensure that nobody could have another access or permissions above the requirement. People also can have multi levels of authentication. Different kinds of authentication have been provided by Azure and AWS. Scalability and elasticity, we have already talked about. As the number of user demands increase, the cloud will make sure that all these resources provisioned will match their needs as well. So that is it for key characteristics. Let's see what are the types of cloud computing services present. So there are primarily three kinds of cloud computing services: infrastructure as a service, platform as a service, and software as a service. In this diagram or chart, you can see we have been comparing it against on-premises infrastructure. While the blue one, light blue one, you can see is the one you or the user would manage. The dark blue one you would see as the one cloud provider would manage. So uh, on the on-premises infrastructure, user would have to make sure everything is correct and upright. Application data, runtime, middleware, operating system, servers, networking, etc., etc. While transforming to cloud computing services, as infrastructure as a service, the user will only have to take headache of application data, runtime, middleware, and operating system. Everything else will be managed by the cloud. On platform as a service, you only have to worry about application and data, and everything, of course, is being managed by cloud computing. And software as a service, you only have to provision this service to your system or applications, and everything is being taken care. You don't have to worry about anything. So next up, let's see what is the worldwide market share of these cloud providers. Let's we have AWS as our winner over here with 32% of market share coverage. Next up is Azure with 23% of shares, Google Cloud for 10% of the shares, and all the other clouds you can see here have less than 5% of the market share for 2023. Well, the revenue generated this year is $63 billion, which is an impressive, and as we have talked that this is the fastest growing industry in the world. Okay, we can have a little overview of AWS as well. Amazon Web Services is a subsidiary of Amazon that provides on-demand cloud computing platforms and APIs to individuals, companies, and governments on a metered pay-as-you-go basis. The genesis of AWS came in early 2000. Well, it is being managed by Amazon, as you can see, and you only have to pay for the resources you've been provisioning. It has different uh, use base. Well, for the diagram over here, you can see the worldwide distribution of data centers and regions provided by AWS. You can see the regions are shown with representing the number of availability zones it has, or the number of data center it consists. So you can see most of these are situated in North American and European regions, and others have been spread all across the world from South America, India, Indonesia, Japan and Eastern China, Australia. You can also see some white uh, circles there, which is representing the upcoming data centers or regions that is being planned by AWS. Okay, next up, let's see what are the services provided by AWS. We have deployment and management services, application services, and foundation services. In the deployment and management service, you have application, mobile, and enterprise application services. On application services, you have administrative and security, deployment and management, analytical services. Over there, you can see compute, storage, content delivery, database, and networking. The last slide or the last column you can see, row you can see represents the infrastructure as a service tools that we all have in AWS. Let's also have an overview of Azure. Azure is a cloud computing platform run by Microsoft. It offers access management and the development of applications and services through global data centers. It was first called Windows Azure and is later renamed as Microsoft Azure in 2014. It has a similar distribution of regions and data. Well, this represents the data centers, not the region, to be precise. Uh, it is mostly similar to AWS. Most of these regions and data centers have been covered in North American and European regions. Others have been spread all across the world. South America, Africa, Middle Eastern, India, Indonesia, Eastern China and Japan, Australia. Well, you might notice that some of these regions are in yellow color. Well, let me tell you that these regions or these data centers are being run on sustainable energy models, which we have talked earlier, well, like solar energy and wind energy models, so as to ensure that they are eco-friendly. Okay, overview of Azure. We are covering the services covered by Azure. You can see more detailed and granular distribution of service models grouping. Over the last row, you as usual you can see the number of infrastructure as a service provided by Azure, and you can have security management, media integration, service compute, application developer services, data intelligence and analyticals, hybrid cloud. Well, let me tell you something. Since Azure is being maintained by Microsoft, most of these services are cap- compatible with Microsoft and Windows products. So you can see more software as a service offered by Azure rather than AWS. Okay, since we have talked about AWS and Azure, let's have a little comparison of both of them. AWS is more configurable and has more global regions. Charging per hour model. AWS EC2 users have more flexibility to configure virtual machines. AWS is excellent for open source developers. While on the other hand, Azure is more compatible with Windows-based system and has more software as a service offering, and it has the per minute charging model. Well, a little drawback of Azure we can see is the lack of configuring the virtual machine. You can only, while provisioning the virtual machine, as we will see this later on in the demonstration, while configuring the virtual machine, you can only select from a given list of images of virtual machines that might best fit your needs, but you cannot configure them. Uh, you have this facility in at AWS. Well, Azure is more tools has more tools for integrating and managing hybrid and private cloud environments. So it is better suited for enterprise and startup environments rather than open source and for individual contributors. If you want to learn about AWS, you can first start off with Cloud Practitioner Foundational certificate, and later on you can go up to associate and professional level certificates as well. and we also have specialty level certificates offered by AWS as well. For more details, you can always check out the official website. For learning Azure, we have more role-based and fundamentals exam. We have three kinds of fundamental exam: AI fundamentals, Azure fundamentals, and Azure data fundamentals. We have some associate and uh, expert level exams as well. So that is it for the cloud computing introduction. If you have any doubts or question, you can always comment in the chat and we will be happy to answer it. And for more details, you can check their official websites, as I said. And now we will move forward with DevOps. I would like to invite Shaibu to please continue from here. Hello, Shaibu.
Yeah, hello, Shruti. Thank you very much, Shruti, for that elaborate explanation and overview of cloud technology. So, hello, everyone. Welcome once again to the workshop. My name is Shabu Suleiman, and I'm a software engineer and also a DevOps engineer. I'm from Nigeria. Currently, I'm working with DevOps for 4 months now, and as a DevOps engineer, I'm the team lead of the DevOps team here at Jubix, and we are responsible for setting up the infrastructure for the deployment of our software platforms at Jubix. And I work with an amazing team that consists of Shruti, Muncha, Daniel, and Samana. Shout out to you all. And as a software engineer at Jubix, I'm responsible for taking up back-end tasks and contributing to our code base in building our microservices. Thank you so much. A big shout out to our team members at Jubix and also the management staff. Thank you so much for the support and all. Thank you so much. So, briefly, we are going to be talking about DevOps. Uh, Shruti went talked elaborately about cloud technology and how this technology actually improves our workflow in DevOps. I'm going to be highlighting some of the tools that can be used on these cloud platforms, be it Amazon Web Services or Microsoft Azure. So quickly, let's talk about DevOps. So what is DevOps? DevOps is a culture and technical approach that emphasizes collaboration, automation, and integration between software development and IT operations to enable faster and more reliable software delivery. I'm going to be explaining the concept of DevOps from two perspectives. The first one is DevOps as a culture, and then secondly, DevOps from the technical perspective or from the technical sides of things. So DevOps as a culture seeks to enhance efficient collaboration between the software development team and also the IT operations team. The IT operations team mostly are people who are responsible for setting up the infrastructure for deploying our software solutions and platforms. So DevOps as a culture seeks to improve efficiency and automate the collaboration between the software development team and also the IT operations. So from a technical perspective, DevOps offers tools that helps in shipping software solution faster, and it automates manual processes in our software development workflow so as to improve efficiency in shipping our software. And that is why anytime we talk about DevOps, we must talk about automation and we must also talk about efficiency, because one of the aim we strive at in DevOps is to improve efficiency in our workflow and in our processes. So, looking at the image on the right, you are going to see some key points or concepts that summarize that give like an overview of DevOps as a whole. So we have practices, we have collaboration, which I can tie them closely to that perspective of DevOps as a culture. And we have concept like continuous integration, continuous delivery, microservices, monitoring, and all that. So subsequently, we are going to be talking about some of these concepts as we progress in the workshop. So let's talk about the CI/CD pipeline, which is continuous integration and continuous deployment, and as it is popularly known, CI/CD pipeline. So what is a CI/CD pipeline? A CI/CD pipeline is an automated process that integrates code changes frequently. It runs tests and deploys software applications, ensuring rapid and reliable delivery from development to production environment. So, quickly, let me talk about continuous integration separately and then talk about continuous deployment also separately. So, taking continuous integration first, the pipeline for continuous integration is mostly responsible for building our application and running tests for our application. So for running the test, anytime there's an update to our code base, when developers code on their local machine and push, there's always an update. The test that is being run in the continuous integration pipeline is to ensure that the new code that is being updated for the software or on the code base does not break our code base. So we already have tests that are running for the application. So it runs these tests and makes sure that what is coming in is not breaking the whole code base. So our continuous integration pipeline is solely responsible for testing and building the application in the pipeline. And one tool that is used for continuous integration is Tecton. We also have Jenkins. And for continuous deployment pipeline, the continuous deployment pipeline is solely responsible for automating the process of deploying our application, be it to the staging environment or to the production environment. And some of the tools that can be used for continuous deployment is Argo CD. Sorry, I might be a bit biased in calling the tools, and reason being that I'm going to be talking about some of the tools we use here at Jubix in automating our CI/CD pipeline. And I'm going to be mentioning some of these tools, like I just mentioned, one Tecton and another Argo CD. All right. So let's move to the next slide. All right. So let's talk about Argo CD. So Argo CD is a tool used for continuous deployment, and we're actually using this tool, Argo CD, in implementing our continuous deployment pipeline. We might not have sufficient time to go into the practical or lab sessions of working with Argo CD hands-on, but we are going to be setting up workshops subsequently where we are going to be taking a more longer period of time to talk about these tools more in-depthly and then get our hands dirty in using these tools at the same time. So let's talk about Argo CD in a bit. So Argo CD is an open source continuous delivery tool that automates the deployment and synchronization of Kubernetes applications, ensuring consistency and scalability within a GitOps framework. Before we proceed, I'm going to be talking about some concept as highlighted in this definition. One is GitOps, and then we are also going to be talking about Kubernetes in the coming slide. So let me talk about GitOps in a bit. So GitOps is one concept that has risen as an industry standard, especially in continuous deployment. So, what is the concept of GitOps? So, basically, the concept of GitOps is using, let's take for example, a version control system like GitHub as a single point of truth in the deployment platform. Now, let me give an analogy of what I just said as having a version control system as the single point or single source of truth. So, in deploying applications on Argo CD, you could use files known as configuration files or manifest files. Now, these manifest files can be either in JSON.NET, in KSON.NET, or Hemchat. as the case might be, depending on what you want to use for your deployment. Now, you can have an image of your application. You can build your application into an image from your continuous integration pipeline. Now, in your manifest files, either using your Helm chart, your JSON.NET configuration file, or KSON.NET, you could pull that image either from a container registry like Amazon ECR, or the container registry for Google. You pull that image in the manifest file, and then you use that manifest file for your deployment. Now, there are a lot of things that are contained or that consist of those manifest files, be it your Helm chart or your JSON.NET files, and which, like I said, we are going to be talking there more elaborately in subsequent DevOps workshop that we are going to be doing. Now, those manifest files can be are stored in a version control system, let's say GitHub. Now, when we use those manifest files to deploy our application on Argo CD, what Argo CD does is Argo CD connects with this manifest file in the version control system. As it connects with it, it keeps checking, it deploys the application on the pipeline, on the Argo CD continuous deployment pipeline, and it continuously check the version control system, which is GitHub, that contains these manifest files, most time in a repository. It checks for any change in the version control system, and whenever there's a change or there's an update, it automatically triggers an update also on the live state of our application on Argo CD. So it continually updates, it continually synchronizes the live state of our application, of our deployed application on Argo CD with the present state of our manifest file in our version control system. Take, for example, GitHub. So that's the concept of GitOps as a concept or as an approach to handling our continuous deployment pipeline. And like I said, also Argo CD is open source. All right, so let's go to the next slide. All right, so quickly, let's talk about EKS, AWS EKS, Elastic Kubernetes Service. So like I mentioned earlier, most times Argo CD is used with Kubernetes. Let's talk about Kubernetes. What is Kubernetes? What is Elastic Kubernetes Service? So Amazon Elastic Kubernetes Service is a managed service offered by Amazon Web Services that simplifies the deployment, management, and scaling of Kubernetes clusters. EKS enables users to run containerized application leveraging the power of Kubernetes orchestration while benefiting from AWS infrastructure and management capabilities such as automated updates, scaling, and integration with other AWS services. So I said EKS is a managed service. So let me talk about what is a managed service. Why do we call EKS a managed service compared to a normal or direct setup you could do of Kubernetes on your local machine? So Kubernetes as a managed service means that the underlying complexity of Kubernetes is handled by the platform Amazon that provides this Elastic Kubernetes service. Likewise, Microsoft Azure, like Shruti talked about earlier, they also have a service called AKS, Azure Kubernetes Service. The cloud platform are responsible for managing the underlying complexity of Kubernetes on their platform. Be it they run automated updates for it. They're responsible for the security, the scaling, and all that. What you just do most times on these cloud platforms is create a cluster and then work with Kubernetes straight on. So Kubernetes as an orchestration platform for our containerized application, you could have we 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 are in a time currently where most times our software solutions, especially in deployment, are containerized in Docker containers. So you could use Kubernetes or Elastic Kubernetes Service to be specific, since you are talking about EKS right now, for managing the deployment of this containerized application on the Kubernetes platform. So you could configure your Kubernetes platform, be it EKS or AKS, with Argo CD for deploying your applications, your software applications. Okay, so can we move to the next slide? Okay, so briefly, I highlighted some tools that can be used for setting up our CI/CD pipeline, which CI/CD is a concept that is part of DevOps. So moving forward, let's talk about cloud computing for DevOps, because one of the things we seek to address in this workshop is to see how cloud platforms offer tools that we can leverage in taking our DevOps workflow to the next level, in making it more efficient, and then the automated tools we get from these platforms. So here we have some points which I talked about, but I'm also going to go over them briefly again. So first, let's talk about collaboration. So in collaboration, we have devs, and that is developers, and the operations team work side by side, understanding each other's challenges and sharing responsibilities. Shared ownership leads to better products and shipping of software solution faster and better. So going a little bit back to talk a little about what Shruti said when she was talking about cloud platforms, and then having on-premises infrastructure, or so to say, let's say local infrastructure. So going a little bit back before the introduction of cloud, or the advent of using cloud and all that, we have companies set up their infrastructure themselves. That is their servers, their firewalls, their routers, and all that. But most times, because they need engineers to manage the complexity of managing servers and all these tools. So most times we have system administrators manage these things. But with the advent of cloud, it happens to be that the cloud platforms manage most of these things for us, be it the server configuration, the complexities of the tools, the networking. We just happen to create virtual networks and all that. When Shruti talked about virtualization, so the coming of cloud computing fosters or enables collaboration between the development team and also the operation team, in the sense that a developer could actually go on and set up infrastructure or basic tools on the cloud. Though I know there are some complexities that actually come with setting up some tools, resources, and infrastructure uh, like that. But then the developer at some point or at some level could set up basic infrastructure on the cloud. Moving forward, let's talk about automation. So automation helps in automating manual processes or repetitive tasks. So on our slides, we have robots to the rescue. DevOps automates everything from testing and deployment to infrastructure provisioning, freeing up human brains for more strategic work. So in the software development process or workflow, you are going to discover that there are some processes that are manual, that you can actually keep manual, or that are done manual. And then you could use automation to automate these processes so as to introduce efficiency. Because most of the times when we talk about DevOps, we talk about efficiency, we talk about automation, we talk about how to automate these processes so as to achieve maximum efficiency. So DevOps helps us to automate processes, be it in shipping our applications, deploying our application, or setting up a CI/CD pipeline. It provides us with automation, and it phases out the manual processes and repetitive tasks that keeps going on in our workflow. So moving forward, let's talk about continuous delivery or continuous deployment. So continuous deployment automates the delivery of code changes from development to production. So every code commit triggers a series of automated tests, builds, and deployment, ensuring rapid and reliable software update. So gone are the days nowadays where you have to spend, let's say, days or weeks in deploying your application. With the introduction of continuous deployment, whenever you just automate your whole CI/CD pipeline, and whenever there's a code commit, whenever there's a change or update in your code base, you automate your platform in such a way that it triggers either in a new a continuous integration or continuous deployment of your platform without lots of manual intervention. So DevOps is actually a game changer in automation of our workflow so as to achieve efficiency. Okay, let's move forward to the next slide. Okay, so gone are the days of requisitioning servers and waiting weeks for deployment. Like I said earlier, with the introduction of DevOps, we deploy uh, our softwares in a very short time, in a fraction most times of the time that is used previously for deploying software solution, so as to keep up with the rapid market and all that. So cloud platforms like AWS, Azure, GCP offer on-demand access to a vast array of computing resources, storage, and networking, like Shruti highlighted earlier when she talked about an on-demand access to resources on the cloud. So developers and operations team can spin up new environments in minutes without having to manage the complexity of working with this infrastructure directly by themselves. So developers can also test and deploy code rapidly and scale resources up and down as needed. This agility empowers DevOps team to experiment, iterate, and deliver value very fast. Thank you so much, Ruti, for highlighting on this point of scalability, having to scale our infrastructure up and down as regards to the demand we have, bit of traffic and all that. Right. So can we move forward to the next slide? Okay. So let's talk about a concept called infrastructure as code. So what is infrastructure as code? Infrastructure as code helps in automating resource management. It brings unprecedented speed, consistency, collaboration, and security to the cloud. On our slide, we have embrace infrastructure as code and unlock the full potential of your cloud infrastructure. So, briefly, let me talk about the concept of infrastructure as code. Let's take, for example, AWS, which is Amazon Web Services. Now, taking Amazon Web Services, for example, uh, you could provision resources in several ways. One of the ways is just going straight to the management console and then provisioning infrastructure. Now, in that method, you could just log into AWS and then you just click. If you want to create an EKS cluster, you just click on that service. You might be required to fill in some details, the name and all that, and then you hit on create. Now, that is a manual way of creating resources on cloud. Infrastructure as code comes to change that. Now, how does it change that? It changes that by using code, most times in YAML files or JSON files, for creating those resources. So you don't have to go to the management console, you log in and then you click, you create the whole manual processes. So infrastructure as code gives you an automated way of creating these resources, basically with code. And some of the tools like AWS, they have their own tool for creating infrastructure using code, which is called Cloud Formation. For Azure, their tool is called Resource Manager. and likewise other cloud platforms. So these tools I just mentioned, be it CloudFormation or Resource Managers, or Resource Manager for Azure, are all tools that can be used specifically for the cloud platform. So they are unique to this cloud platform. CloudFormation is unique to AWS, and Resource Manager is unique to Azure. We have a very popular tool in the industry. It's a third-party tool. It's called Terraform. So Terraform is a third-party tool that is used for provisioning infrastructure. You could provision infrastructure across AWS, Microsoft Azure, and Google GCP. So Terraform was created by HashiCorp, and like I said, it's a third-party tool and can be used across cloud platform. So it's not unique to just one platform. We also have other tools like Ansible, Pulumi, Chef, and others. All right. So that's a little bit about infrastructure as code. So, like I said earlier, still just trying to emphasize that in our subsequent workshop that are going to be coming on, we are going to be going more in depthly in not just in talking about these tools, but in using these tools hands-on practically in lab sessions, so that we all could know how they work and how to use them and how they could actually improve our software development life cycle or workflow. Okay, let's go to the next slide. Okay, so let's talk about enhancing business efficiency with cloud computing. So, how is business efficiency enhanced with cloud computing? As we all know, be it you're working on a software as a company, as an organization, as a personal individual, most times there's always a business agenda behind it. You want to create a software and put it out there that could actually either be of impact to users, you want to solve a problem, or you want to generate income or profit using that software. So how does it enhance business efficiency? How does cloud computing, how does DevOps enhance business efficiency? So let's talk about the first point. Cloud computing boosts business efficiency with scalable resources and cost-effective pricing. Earlier, Shruti talked about scalability and then the difference between cloud platforms and having on premises or setting up a local infrastructure. Now, compared to cloud, you are going to discover you actually use services on demand. You don't need to have to go through the extra stress and hassle of setting up servers, hardware servers, configuration, looking for system administrators to manage all these. No, you don't have to do that. You just make use of your cloud platforms and spin resources or infrastructure in a matter of minutes, and you have your infrastructure already up and running, which actually uh, gives you an edge when we are talking about time and then the speed of delivery. Next up, let's talk about the cloud computing or cloud technology facilitates quick product launches with streamlined infrastructure, reducing time to market. So I see these points going hand in hand, let's say complementing each other. Talking about having to scale resources, being it cost effective, and now talking about having quick launches of your product. So you could imagine if you could spin up an infrastructure very quickly in a matter of minutes. It means you can set up your infrastructure. I'm not saying you can set up your infrastructure in a matter of minutes. No, that's not what I'm saying. I'm trying to say that you could set up your infrastructure, your services, and resources in a short time, which will actually improve your product launches. In talking about the time it takes to launch a product and the time to market, as we all know, we live in a very uh, fast-paced lane in technology right now, where you have to release updates very fast in time just to meet up with the competition and all that in the market. So cloud computing is actually a game changer in giving you an edge of that speed and all that in time to market your software solutions. So cloud computing also significantly cuts IT expenses by eliminating extensive hardware investment, optimizing resource utilization. So let me give an analogy of that. Let's take, for example, you want to set up an infrastructure, and maybe you have an estimate of the kind of infrastructure you want up. Maybe that decision is being influenced by the traffic you are expecting or the kind of application you are delivering. Now, in going to that stress or hassle of having servers on your own and all that, and then the decision changes or something changes along the way, you discover that the whole hardware you have, the setup, the infrastructure, and all that, it could actually be uh, it could actually be a waste, or those resources cannot be utilized optimally. So cloud computing actually comes in that place to improve resource utilization and then optimizing how we use especially hardware resources, because you can either decommission or commission or spin up resources as you wish. So you could actually create a virtual machine with configuration of the CPU, the RAM, the storage, and all that. And if you want to scale up or down regarding to your needs, you could do that without having to get those physical resources or infrastructure on site. So cloud actually improves resource utilization and the optimization of our hardware resources. Okay, can we move to the next slide? Okay, we are on our next slide. All right. So let me hand over to Shruti. Yeah. Thank you so much, everyone. That's a brief overview of DevOps, and also how cloud computing is actually a game changer in be it DevOps, software development, and other fields. Now, just on a quick one, our discussion about cloud today was a little bit focused on software development and all that, but cloud computing has a lot of possibilities. It can be used for a lot of things, but for our focus, we just talked about DevOps, software development, and all that. So thank you everyone for joining. Over to you, Shruti. Thank you, everyone. Okay, you are mute.
Today,
Shruti.
I'm mute.
Yeah,
Um,
I can hear you. Go
hello.
ahead.
Okay. I was saying that you did an amazing presentation today. You have very detailedly and precisely talked about DevOps and how we integrate cloud computing with DevOps. So next up for our demonstration and little practical session over, we will be taking up a little real-time, real-world scenario where, uh, can you please show my screen up here? Okay. This is the scenario which we will be constructing it on Azure platform. So in this scenario, we have a virtual network. In this network, we have three different tiers of applications: website tier, application tier, and database tier. The main deal over here is to configure the networking rules between them. So these rules have been written over here. The web tier should be able to access the internet and should be able to access the app tier. The app tier, on the other hand, should be able to access the web tier, but and database tier, but not the internet or any other uh, platform. Next up is the database tier. This application should not be able to access neither the app tier nor the web tier or the internet. Only app tier is able to access the database tier. So we will be building this on our Azure platform, and you can also follow along if you want. So let's go up to our portal. We will be creating it from scratch today. Huh. Hmm, let us sign in. Okay. For this infrastructure, we would first need to create a virtual network which will have all these different kind of tiers in it. So we will click on the create and we will see a little application or form. For the resource group, you can see in Azure we have resource groups so as to segregate different kinds of applications or web shop workshop. Okay, sorry. So the resource group is the one that manages different kind of services or groups them differently. Okay, let's name our virtual network workshop network. Let's have the region as US. Next, security leave it at default, and let's create 3 subnets, each for different application. Okay, web subnet, which will have starting address of this. Okay, I will add it. So I think I was editing this. Let me create it another way without using default because we don't need default this time. We only need web. So let's start with the web tier subnet. So this is the web tier subnet. Our virtual network has a range of 65,536 addresses ranging from this to this, and our web subnet will only be covering these ranges. Let's add another subnet. Okay, this will have a starting address of 1.0. So you can see as we create the subnet, all these subnets have non-overlapping CIDR ranges, but all of them can be connected internally. DB. Okay. Next up, we don't need any tags, so we can review and create this network. This might consume a little more time. Please bear with me. Okay, it has done the validations. Now it is initializing the deployment. I have previously worked with Microsoft Azure, so it's a little easier to navigate and know how, how these works. Okay, so we have already created 3 subnets and we will now create virtual machine for each subnet, which will be the one responsible for running these applications. We will click on the create button of virtual machine. Make sure that we are using the same resource group as we did for creating our virtual network. Web VM. Okay, I am all good with this image and size. Let's have our authentication. These are required while we connect to this virtual machine. Okay, I will set all the inbound ports because we will need the internet access for this virtual machine. For disk, I am alright with the default. And for subnet, okay, we have workshop subnet network, and in it we have web subnet. Okay, leaving all the other details as default, we are now going to create our virtual machine. First virtual machine. You can see all the pricing and every summary of the while creating this machine on the last page as a confirmation. Okay, the deployment is being initialized. We can have all the notifications here. Okay, it will be deployed in just few minutes. Let's create our next virtual machine, which would be for app tier. We will do again the same thing. We will choose our resource group, name our virtual machine. It's located in same zone, same region. This time I'll only allow SSH ports because I don't need internet access or any other HTTP access. Okay, disks are alright. Network, it's already in app. Subnet, everything else is good. We can review and create it now. It's a little slower today. Okay, the deployment is in progress again. We will create another virtual machine as well. Following all the previous steps. DB VM. This again is kept out for internet access with SSH only inbound. This is an app tier subnet. Everything is fine. Let's review and create it now. While we are on it, I will create cmd portal create button. Okay. I'm just waiting for that deployment is in progress confirmation. Okay. So we already have 3 virtual machines prepared, and let's just connecting them. Okay, connect. Okay, to connect with this, we have two options. One using Azure CLI and another using our local command prompt native SSH. We will be using native SSH because uh, it's a little easier. Okay, let's connect to this. We will use the private key. Yes. So this is the private key, and you don't need to download this key to connect it with the machine. My password. Okay. Something wrong. If that is the case, okay. If that is the case, I would probably go back to my previous created virtual machines which have been stopped and start them again. But I don't know what is wrong with my password, and if there is something wrong with my password, I would not be able to access the machine from either way. Starting and
It's
is
all
the
right.
ping set? Sorry?
Let's use the virtual. I said it's all right. Let's use the virtual machine you created previously.
Yeah, yeah. I don't know what's wrong with my password today. I've been using the same password. Well, never TPPM. Okay, they might take some time to restart again, but let's have our diagram over here so as to keep in flow with what we are going to manage. Okay, let's see if our first machine is ready. Okay, it's running with VM connect. Let's try and connect with this. This is the private IP address to connect with this machine. Okay, let's try with this. Hmm, no. Oh, it's working now. Thank God. App VM. So we will create another some CMD prompt for app and another for database. Okay, good. Database VM. Okay, so as you can see, we are able to connect with these services, and let us try if they are able to connect to the internet. We can use ping command to check if it's connecting. Yeah, for now it is connecting because I have not set any traffic security rule. So all of these would be working same. If I ping Google or any other service, it should be able to connect as these are all in same network. Okay, so let us go ahead and create the network. Okay, let us draw our this diagram because we need this one. Okay, so the app DB should not get connected to the web. So we will create an inbound security rule and name it as deny web action to deny. Source IP address would be for the web 0.0.0/24. That is the IP range for uh, web virtual machine which we have created. Destination would be the same as DB virtual machine. We will have all the destination ports allowed, and okay, so you can see the priority is a little lower than SSH priority. We can change these priority rules. Also, we need another outbound port rule which would deny the access to anything on the internet. The source would be any and the destination would be any. All destination port ranges, deny any outbound. Okay. Let us create all the networking rules for all machines and then we can check again. We have next up is app virtual machine. No, not connect, network settings. So the app is allowing inbound from web. So first off, let's create inbound rule for traffic from web. Source would be IP address. IP range of web is 0.0.0.0/24. Destination would be for app 1.0. Okay. Allow from let's just do it quickly because we have lost so much of time. Oh, we don't need any other inbound. We only need outbound for web and for TV. Let's just do that quickly. Outbound to 0.0. Okay. Source. Allow to web. Okay. Another for DB. Two point zero. Alright. DB. And another one we would need so as to block access to the internet. This would need another separate outbound rule. Source would be the same IP address of app and destination would be any. Deny any outbound. Perfect. Okay. So we have 5 rules set up. Okay, last one is for web VM. we just need one rule which would allow the traffic from app tier, another inbound rule. Source would be app tier 1.0/20. Okay, let us now test them. I don't think I would need any other rules. Okay, let's see with the web app, what can it ping, what can it not ping. It is able to access Google. Yep, it can. It is able to access database. No, app. Yes, it can. 0.4. No. So the web should not be able to access the database, so it can't. So this works perfectly fine. Let's see for the app tier. It should be able to connect with web and database, but not the internet. Ping google.com. Okay, good. It can't connect to the web. Oh, sorry, internet. Ping 10.0.0.4, which is the IP for web app web VM. It can be connected. 2.4, no, 2. Okay, perfect. And we have already checked for database VM. Let us have it checked again. 10.0.1.4, which is app. It can't connect it with it. And for web, it can't. Perfect. Okay, so we have successfully accomplished to create this networking model for all these different kinds of database successfully. Okay, so I will now
Well
stop
done.
sharing.
Well done, Shruti.
I got a little panicked when my password didn't
Well
work.
done, Sri. I was like, wow, your patience is really, really amazing. You were like, okay, don't worry, you gotta wait. So that was really, really enjoyable. I think you guys both did a really, really fantastic job. I even learned a lot myself about DevOps, and I'm sure our audience. So just let you know that a lot of the comments that are being said on LinkedIn, um, I'm not able to see them via StreamYard, the platform we're using to stream this live today. But I hope most of your questions have been answered by our fantastic experts for this afternoon, Shaibu and Shruti. So yeah, just to let the audience know, now, obviously, all our workshops, our series of workshops are completed now. But going forward, we're going to be having an extended workshop, which would have a fee equated to it. So, you know, definitely look out for those workshops, which will be going on in early summer. So it will be probably around 6 to 12 hours based on the topic in question. And it will be with the same facilitators as you've seen previously, as well as today. So congratulations once again, Shaibu and Shruti, for your fantastic presentation this afternoon. And yeah, I think that's all for this afternoon. Is there any other questions from our audience? I know there was a question from George, which I answered. So the recording will be available via LinkedIn and YouTube. And also any of the other previous workshops that you've missed have also it will also be on YouTube and LinkedIn. In regards to Juby points, so I think some of the older members that attended a lot of workshops, we've talked about Juby points. So you'll be awarded 15 Juby points for every workshop that you have attended. So out of the series of workshops, we're going to now go over those workshops and see who actually attended those workshops, and we'll be drumming up a drum roll for those contestants who have got those points and see what prizes that we have in store for them today. So thank you once again to our audience. Is there any last comments from Shaibu and Shruti?
This was an amazing experience with this workshop, preparing it and having a chance to speak it on the live session for the first time. So I'm really happy today and thankful to you guys.
And you did so well, Shruti, so you should be. Shaibu?
Yeah. So thank you everyone for joining the workshop. It's been amazing. Even working as a DevOps engineer here at Jubix. Like I said earlier, in this workshop, we didn't do a lot of hands-on practice, especially with some of the concepts in DevOps and also the CI/CD pipeline. But just like Susan highlighted earlier, we're going to be having more workshops coming your way, which they are going to be hands-on. We're going to be having lab sessions and going in-depthly on how to use these tools and get our hands more conversant using these tools practically. So yeah, thank you so much, everyone. Thank you.
Amazing. And like we said, GTLRA is all about diversity and inclusion. That's why you see a diverse amount of speakers, because everyone understands in different ways. So once you have a diverse speakers that maybe speak your language, we all speak in English, but the way that we speak maybe lends the ear to some more than others. So thank you once again to our audience, and thank you once again to our speakers. I would like to conclude this session for this afternoon. Thank you once again, and take care. Bye-bye, everybody. Bye.
Bye.
Do you want to say bye, Shaibu?
Bye, everyone.
Bye. Bye. Take care now. Bye. Till next time.
Bye, everyone.